Hello folks, so in this video I want to talk about how we can use this thing called the factor theorem to figure out whether something is a factor of a polynomial or not. So I worked through these two division problems, and for the purpose of keeping this video short I didn't actually show the division, but in these cases we have the exact same dividend, the starting polynomial, x cubed minus x squared minus 14x plus 24. Now if I divide it by x minus 3 I will get this quadratic x squared plus 2x minus 8 with a remainder of 0. So I didn't have to really write that, but I just wanted to point that out. In the second example, where I divide that same polynomial by x plus 7, I got x squared minus 8x plus 42, but I got a remainder of 270. The important part is that the remainder is not 0. What this means is, well, first off, let me kind of shorten this so that I don't have to say it every single time. I'm just going to call that starting polynomial, that numerator, p of x. P for polynomial. So it's just a function of x, and I decided to call it p. Okay, so what we can say then is that because we divided it evenly, or it went in evenly, x minus 3 is a factor of p of x, that what we started with. Because again, the remainder is 0. The remainder equals 0. There's nothing left over. Just like how we would say 4 goes into 8 evenly because there is no remainder. But it doesn't go into 9 because there is a remainder. Likewise, we could say that x plus 7 is not. That's all. N, sorry about that, is not. And I'll just say a factor of p of x. Again, because the remainder is not 0. Okay, so this still begs the question, like, how do I figure that out? So that's our driving question for today. And I'll write that down. Our driving question, is how do I pick a divisor? That's our question. Let me make that bigger for you. Well, again, let's think back to what this means. So because x minus 3 is a factor of p of x, this is what we can say. Is that we can say that p of x is actually equal to, besides saying the original long cubic, we could also say that's equal to x minus 3 times x squared minus, I forgot what it was. Was it 2x? Yeah, plus 2x minus 8. That's a plus, sorry. Okay. Now here's my question. Think about this. What does having a function in its factored form let you do? If we think back to quadratics, because this is where this came up a lot. So let's pretend I have some function f of x, and let's say it factors into x minus 1, x plus 4, say. Well, you might remember that the reason you want to factor things is because a lot of times it helps you, well, when it is factorable, it lets you easily find the x-intercepts because you can use our zero product property. And we do that by setting f of x equal to 0. And now, well, a zero product property says if I'm multiplying two things and the product is 0, then one of them must be 0. So this means this has x-intercepts at x equals positive 1 or x equals positive 4, or sorry, negative 4. This would mean then that f of 1 is equal to 0, and likewise f of 2. Sorry, not 2. I don't know where I got that from. F of negative 4 is equal to 0. The same rule applies here, even though it's not a quadratic, but the zero product property still applies. So check this out. When does, or by when I mean like what x value, when does p of x equal 0? Well, that would mean either this part equals 0 or this quadratic piece equals 0. Now we won't get into quite this part because we wouldn't have figured that part out yet anyway, but we can see that in its factored form, p of 3 is equal to 0 because of zero product property. But I can also check at the very, very beginning. So let's pretend I didn't know that this was going to work in the first place. I believe our original function, p of x is equal to x cubed. I'm going to copy this. I'm just going to grab this and copy it. Stand by. Let's just get rid of that. So we would want to double check this, and we will right here. So does p of 3 equal 0? So obviously in its factored form, it does. We can see that. But if I didn't know that, p of 3 is equal to, let's see, 3 cubed minus 3 squared plus 14 times 3 plus 24. So let's work through this. We have 3 cubed is 27 minus 9 plus, what is that, 42 plus 24. Almost there. This one's a little bit long because it is a cubic, so it will take a long time. 18. Did I copy something wrong? Oh, it's minus 14x. I apologize. There we go. That's what I thought. Minus 14x. Because I could tell it wasn't going to work. Minus. There we go. And so we have 18 minus 42 plus 24. 18 minus 42 is going to be negative 24 plus 24, which is 0. And so indeed, p of 3 equals 0. And so because we know that, we already know that one of the factors is going to be 3. Or sorry, jumping a little ahead. This means that x equals 3 is an x-intercept or also a root. An x-intercept or a root. Those are, again, similar words of p of x. And therefore, this tells us that p of x, one of the factors, is going to be x minus 3 times, something else. How do I get to something else? This is when we use the long division, or you could divide using the generic rectangle. So there's actually a theorem for this, and let me write that up for you. Okay, so this theorem has a kind of a fancy name. It's called the Factor Theorem. It is capitalized, of course. So if you have some polynomial p of x, then you can pick out one of the factors, and that factor will be x minus, say, b. B is just some constant. If you can plug in b, and you get 0. Again, this would imply that, hey, if this is the case, then, so again, this is like how you would check. You would plug in some number, b, get to equal 0. Okay, this tells you that b is an x-intercept. And this would mean then that p of b, if p of x is equal to, say, x minus b, something like this, and then a bunch of other stuff, then when you plug in p of b, that means p of b equals 0, would be equal to b minus b times, again, whatever the stuff is, which would equal 0. Oops. So that's kind of the reason that this works out. It's not always obvious as to what b is, but for now, that's all we need to know. In the next video, we'll figure out exactly how do I even start guessing what b would possibly be. Pun intended, I guess. Alrighty? So thanks for watching. Hopefully this makes some sense, and I'll see you in the next video, folks. Stay spicy.